first unit. The first 3 lessons are just kind of summing up, or not summing up, just, well, 8.2 and 8.3 are kind of summing. 8.1, didn't quite know where to put this, but it has to do with integrals, so I just figured, hey, it would be a great place to put at the beginning of a unit. Our last 2 to 3 lessons are really cool, really cool. And it kind of brings calculus full circle, and you can do some really neat things with it. I feel bad for ACP that doesn't get the last 2 or 3. It has to do with area and volume. But anyway, before we get there, these are real quick little lessons here. We want to figure out the average value of an entire function, at least between a certain interval, or within a certain interval. And remember, your function, I mean, it could be, it's not consistently high, consistently low. It's not as high the same amount as it is low, so we kind of have to do a weighted average here. So it's, I say up here, it's pretty easy to calculate the average value of a finite number of numbers. I mean, we know how to do that. But how can we find the average if infinitely many are possible? So about how to, for instance, how about the average value of a function? And I want to go from A to B, but I know I want an infinite number of y values. I mean, it's gonna, it could be that every single y value has a different value when I use it. So the average height of a function will be equal to the area under the curve divided by the width. The area under the curve divided by the width. And we can find it by doing the following. So we'll start by dividing the interval from A to B into n equal subintervals. Does that sound familiar? N number of rectangles, each with a consistent width, change of x, b minus a over n, however many rectangles you want. And then the average will be, well then add up, you know, all the x values you're going to plug in, divided by n, the number of rectangles you're going to use. And then through all of this stuff, I don't think you have to memorize this stuff or even write it down, I'm just showing you. We really want an infinite number of rectangles, so all of that becomes the average value of a continuous function on a certain interval. We can say f average, sub average, is 1 over b minus a. Hey, b minus a is the width, right? Times the integral from a to b of whatever it is I'm trying to find the average value of. So basically, it's the area under the, because this is going to give me the area under, I keep saying the area under the curve, I mean to the x-axis, right? This will give me the area under the curve divided by the width. That's what we're doing. Area under the curve divided by the width. Or multiplying by the reciprocal is the same as dividing. And this is equivalent to an infinite weighted average, because I'm getting the area under the curve. Hey, there's an infinite number of x values I'm plugging in. Each one's probably going to give me a different y value. Okay, that's it. So we got to know this. This is a great thing to put on our yellow sheet. The average value of the function. The area under the curve divided by the width. Area under the curve divided by the width. Area under the curve multiplied by the reciprocal divided by the width. and no, we'll do a couple of examples if you want. So a great thing for the yellow sheet, average value of the function. Of course, if the function is constant, the average value is going to be whatever the constant is.
That's this one? Yeah.
So average value of the function is equal 1 over b minus a, I can pull that out, is the width, that's gonna be constant, and we're dividing by integral from a to b, whatever the interval is. The function, I'm trying to find the average of, which is the area under the curve, or the area to the x-axis. Net area under the curve, right? So sometimes it can be negative. Are you ready for some examples?
Yes.
Here we go. Okay. Here's example number 1. Find the average value of the function 1 plus x squared on the interval from -1 to 2. Okay. So I want to find f average. And that's going to be 1 over b minus a, the integral from a to b, f of x in terms of x. So, using our values and our function here, we're going to have 1 over 2 minus -1. Times the integral from -1 to 2
I'm sorry.
of 1 plus x squared dx. And so out here, I've got the width being 3, so 1 over 3. 1 over 3 is the same as dividing by 3. And then I want to take the integral of the inside. Because I'm adding or subtracting, I can do each piece, right? This would be x to the 1 over 1 plus x to the 3rd over 3
Yes.
plus c? No, because we have a definite integral, it's going to give me a numerical value. Okay, but I do want to take this part from -1 to 2. So let's say I got 1/3 out here. And so let's plug in the big number 2 plus 2 cubed over 3. And then minus, we'll plug in the low value, which is -1. -1 plus -1 cubed over 3. Oh, I was writing too big. So that's going to give me, we do each little step here so you see where the pieces come from. 2 plus 8/3. 2 plus 8/3. Then I got minus a -1. That should then be plus 1, right? And that's going to be -1/3 minus a -1/3 plus 1/3. Now I probably need to put all that together. Let's see, I got this 1/3 out here because I still have to divide. This is just the area under the curve, and I still have to divide by the width of 3 or multiply by 1/3. So 2 plus 1 is 3.
28 over 3.
Is that what you're gonna get as the final answer?
No, it's 18 over 3. That's what I got.
Well, why would you not? You can just do a divided by 3 plus 1/3, and it's going to be 3, and then it's 2 plus 3 plus 1.
And then if I do 8 plus 1 over 3, right?
18 over
Which will be my 1/3 out here. 3 plus, well, that's gonna be 9 over 3, right?
Mhm.
So that's just
3. And then 6.
3,
And then 6 divided by 1/3.
which is 1/3 of 6.
Just total.
The area under the curve is 6, divide by 3, I get 2.
Nah.
That is the average value of the function.
Nah.
Sometimes it takes on a value higher, sometimes it takes on a value lower. But on average, that's what it is.
13, 14 turds.
Shut up, bro.
I mean, if you wanted to, you could have gotten everything in common denominator. Although, guys, you could have left the answer in
Yeah.
there. If it was a free response. Now, multiple choice, they probably wouldn't have an answer option. It would be that. But a free response, if all you have to do is the arithmetic, they don't want to see the arithmetic errors.
That's not it.
Hey, what's
Mayo.
questions? No? No question? The long fingers. Do you play piano? Do you? Seriously? Yeah, because you got some long fingers.
You play piano?
Yeah.
Oh, me too.
That's right.
Do you? Do you play piano?
Mhm.
You play piano? You play piano? I play piano. That's fine.
And
You
Effie
play
plays
piano? Ah.
Effie plays piano.
What? What is?
Wow. You two that don't play the piano. How embarrassing. Okay, let's see what number 2.
Gulp.
Yeah, I can go.
Okay, so we're gonna find the average value of this function over the interval from negative pi over 2 to pi.
Have to do that challenge.
Nothing
You
else
gotta do
different.
that challenge. 2 pizzas, 2 2-liters, a pizza each, and then 2.
So let's see. F
That
average
sounds pretty good.
is gonna be 1 over B minus A, right?
Yes.
Well, we probably already know what that's gonna be. Pi over 2 plus another pi over 2, but we'll write it down. Pi over 2 minus negative pi over 2.
Cause I just buy.
Integral from negative pi over 2 to pi over 2 of the function to cosine x dx. So that's gonna give me 1 over pi, right? Out front. Half a pi plus half a pi is the whole pi. So that's what I want to divide by. And then I want to try to figure out the area under the curve. So what's the integral of 2 cosine? 2 sine. Or we could pull the 2 out if you want. Okay. 2 sine
You better get it with the house.
plus c plus c.
No.
No, because we're taking a definite integral. I gotta move that up. Getting in my way. From pi, negative pi over 2 to pi over 2. That's that. So that'll be, I want to divide by pi the area under the curve. So 2 sine pi over 2 minus 2 sine negative pi over 2. Hey, what's sine of pi over 2?
Like one.
Yeah. Remember, sine starts at 0 and this goes up.
I just
to 1.
said.
So that'll be 2 times 1 minus 2 times. Hey, what's sine of negative pi over 2?
Negative
Negative
one.
one.
Yeah, 'cause if it's going up to 1 here, backwards, it's going down to negative 1.
Or we see.
Okay, do it.
There, I'm gonna divide by the width.
Do you know what I've done?
2 plus 2. Is that what I get in there, 2 plus 2?
This.
Which I think is gonna give me area under the curve is 4, the width is pi, so
Pi.
why don't we just say 4 divided by 4? Which, I'm okay with this. Although I'm always telling pre-calculus, you would never have a fraction with a decimal. Which, I know that's a decimal, but not really. It's a sign.
14 turns.
Bro, the moment we get the video, we.
So one of the things I wanna make sure you guys know are the basic like sine, cosine values. So before the AP test, they're gonna ask you basic, you know, pi over 2 pi, 3 pi over 2, 2 pi. They're gonna ask you those for sine and cosine. And if you know sine and cosine, on the off chance they ask you tangent or secant. Cotangent is just sine and cosine. Questions on this?
It's like what we would have.
Should we do it one more time? Okay.
Why not?
We'll do it one more
Why
time.
not?
And that'll save number 4 as a warm-up tomorrow. Let's see. Plus I like
What if we do number 4 tomorrow?
What if we said to be like number 4 each piece? Oh shit.
I wanna know what you get. It is a multiple choice. Good. Gonna cut off the top. Or I'm gonna cut off the top.
You know what I've done to people like you?
Okay.
Do you know who I
Hey,
am?
we can set this up together. Average value of the function. See, I wanna go from 0 to 2. So I bet the width is 2. So I'm gonna divide by 2, multiply by 1 over 2. 2 of x squared.
Where'd you get the gym? You know who I am? Monk.
How are you guys taking the integral of that function?
You can
Use
select
substitution.
U substitution. I like that. Let's let you,
Just start with me.
because if I take the derivative of this, I see it right there. So let's let u be x cubed plus 1. Du will be 3x squared dx. Guess what? I see x squared dx. Right?
Yes.
Okay. So if I just divide the 3 over there, x squared dx, which is, can't see that. I can turn that into 1/3 du, or du of over 3, whichever. So that means I've got the square root of u, and then x squared dx can be 1/3 du. But you know what? If I changed x to u, why don't I go ahead and change the intervals of integration? Wait a minute, who forgot to do that?
Are you sure?
Ah,
If you're right, you get more mayhem,
Drake.
bro. No!
It was Drake. He forgot, so he had to do a longer problem. Okay, so if x is 0, u is 1. And when x is 2, u is 9. U is 9. Sounds like bad English. U is 9.
You get it?
Okay, that means I don't have to plug x
Of course
back
you
in.
would.
Okay, I just changed the
I just
interval of
This is
integration.
my problem.
And so I could probably pull the 1/3 out with the 1/2 and call it 1/6.
When I was about that,
Integral of 1 to 9 of u to the 1/2. I feel like I'm doing this whole time. I wanted to see what you guys do. Man, Mike.
I think I did something wrong.
I didn't get it. Yeah, I got it.
Wait.
Oh, interrupted.
No, I feel like I did everything right.
Again, when I have a rational exponent, I take the root first and then multiply.
Oh,
Especially if I don't have a calculator. I'd much rather make a smaller number first. I don't wanna raise 9 to the 3rd power and then take the square root of that. I'll take the square root of 9 and raise that answer to the 3rd. I think I got my answer.
I have a question.
Mhm.
It says 1/6 times the quantity of 2u to the 3/2 over 3. How
Mhm.
did you get that 2? That's next to the
Oh, because when I took this integral, that was u to the 3/2 over 3/2.
Oh yeah.
So I just flipped it.
Yeah, yeah, I see.
I think I got it.
No, that's good, because somebody in New Zealand would have got the same question.
What's your name?
Yes. Yes, I was about to ask. Hopefully everybody got A's. If I have a circle.
I messed up. I went back to you.
1/9 times 26. Area under the curve divided by, that's more than the width.
The meal is helping.
He's pointing me to the right answer.
Hey, that's the average value of a function. So I was gonna give you guys tomorrow to work on this. But that being said, who